This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 211. Today's presentation is assessing the economic benefit of the next generation geostationary satellite hyperspectral ocean color instrument, the Geostationary Extended Observations GeoXO OCX. I'm glad to have Mike Jamilkowski, also known as Jammer from the Aerospace Corporation, with us, and Tracy Rouleau, the president of TBD Economics, with us today. Following the presentation, we're glad to have a discussion facilitated by Scott Lindstrom, a scientist and trainer from the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison. As you just heard, this session is being recorded. We ask that if you are in the audience, you mute your microphone and turn off your webcam, unless you're asking a question as part of the Q&A session. And for that Q&A session, we ask that you post your questions in the chat and we will field them in the order they are asked. Though if you have a complex question that you'd like to engage with our presenters on, you can feel free to note that and then unmute your mic when called on. Also, if you have not signed in with your full name, perhaps you're using an office account, please note your name when asking a question in the chat so we can follow up if necessary. As always, we're looking for future presenters, so if you want to become part of the Satellite Book Club Seminar Series, we would love to have you, and please contact the Tower S team for that. Also, there is a form that is in the chat that will help us connect with you. The training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Ross Van Til with the Office of the Chief Learning Officer can help with that. I'd like to thank the OCLO, the Geo and Leo programs, our presenter, facilitator, and all of you for being with us today. Special thanks to Kashad and Emily for helping with the Satellite Book Club behind the scenes each and every week. Couldn't do it without them. All right. Without further ado, Mike Jamilkowski retired as colonel from the U.S. Air Force, career as a weather and space operations officer in 2002. He then worked several years for Raytheon as their program office manager on the NPOESS, NPP, and JPSS ground system programs. He holds a bachelor's and master's degree in meteorology, is an AMS Fellow, and graduate of the U.S. Air Force Undergraduate Space Training School. Joining him today is Tracy Rouleau, the president and founder of TBD Economics, LLC, which provides economic analysis to government, private, and nonprofit firms. She's a senior fellow at the Center for the Blue Economy and non-resident fellow at the Stimson Center. Prior to starting TBD Economics, she was deputy chief economist for NOAA. Her research interests center on valuing benefits provided by nature, understanding and advancing the blue economy and the value of information, and the intersection of climate change risk and coastal resilience. She holds a master's degree in environmental studies, coastal resource economics from San Jose State University, and completed her PhD coursework in exams in marine policy and fisheries economics at the University of Delaware. Jammer, we are glad to have you back at the SBC, and Tracy, welcome.
Well, Jordan, thank you for that fine introduction. Appreciate that, and good afternoon or morning to everybody. I want to thank the Satellite Book Club managers for having me back to discuss a topic that is somewhat slightly off the core mission of the Satellite Book Club. And background is in several of the environmental satellite programs that I have had the honor to participate, the lack of good, strong economic justification always seemed to be lacking. And so that's why I jumped into the chance to be part of this, the second of our two GEO environmental satellite economic benefit studies. The first one we just finished for the GOES-R ABI early last year. But even more challenging in the second study, we're assessing the future potential economic benefits of the ocean color sensor. And our study team, mostly listed here, was spearheaded by TBD Economics, LLC, and TBD is their name, not an acronym, and for which their study team leaders are listed, Tracy, as you see here, and also Jeff Adkins, their senior economist. Next slide, please. So I will be quickly covering the first 2 or 3, 4 bullets there, and that's mostly background. And Tracy is going to come on. We're doing a tag team here to cover the economic part of this, which I could never do, and our preliminary results. Then we'll have some Q&A. Next slide. So a lot of you know what the GeoXO is, and basically it's just going to be the follow-on to the GOES-R satellite system. Going to be fielded in the early 30s and has a planned 3 satellite constellation, as you can see in the graphic at the lower right. It carries several of the instruments similar to the GOES-R, the VIS IR imager and the lightning mapper, but it's planned to have several new instruments, which is a hyperspectral IR sounder, long time coming, atmospheric composition, and the ocean color. And this presentation is really focused on the ocean color. Next slide. So why are these products important to end users? I think I really put this slide in because I think a lot of the viewers here are National Weather Service people, and we don't always look very hard at the blue economy, the blue or the wet side of NOAA. And so if you look at this, the marine economy contributes almost $500 million in economic impacts to the U.S. economy. And so having these accurate and up-to-date ocean color products are very important to that economy. So OCX is going to look at several pieces of the ocean science and assess things like productivity, ecosystem change, as you can see listed here, coastal inland water qualities, seafood safety, and hazards like harmful algae blooms. I know everybody's heard of that. And so there's a nice graphic in the lower right that kind of talks about all those different kind of products that are important. But the OCX will be collecting data within the U.S., what they call the exclusive economic zone, EEZ, and it is in purple in that map on the lower left. And as a geostationary satellite, this is as much as that can be observed, which is quite a bit. Next slide. So here's a quick review of some of the improved capabilities. If you look at where ocean color data comes from and products, they are derived currently from mostly LEO environmental satellites like NOAA JPSS VIRS and NASA Aqua and Terra Modis. And they have a shortcoming. They can only look and refresh once per day. And so if there's anything in the way like massing clouds, sun glint, or other blocking phenomena, those data are unavailable and the derived products are going to suffer from data lags. It also limits the ability to capture diurnal variability in common, which is common with HABs, harmful algae blooms. So the OCX data refresh rate of 2 hours is going to significantly minimize those obstructions, and especially over the EEZs. And furthermore, the sorry, I got backed up there. The OCX is going to have a hyperspectral instrument, and the LEO instruments right now only have multispectral. So, for example, there's going to be approximately 350 channels on GeoXO OCX as compared to 20 to 30 on VIRS. Next slide. So I know this is a bit of an eye chart, but I wanted to put together a collection of the current and future space-based ocean color instruments to show you the comparison between those and GeoXO OCX, which is the very bottom line there. And as you can see, it has the most highest utility features there, except for glimmer. Now, glimmer is going to be going up in about 3 years, and it's going to be a NASA, mostly a research satellite, and it has very much the same characteristics as OCX, but we're going to learn a lot from it. The difference there is that OCX is going to be up for almost over 20 years, providing operational data to several different organizations. Next slide. So we wanted to list some of the major applications of the OCX observations here, and you can see HABs are the first thing. We have talked to oceanographers, and there's been a lot of research that TBD did and came up with these as the major ones. But as you can see, next slide, we are concentration on harmful algae blooms in this economic benefits analysis. And so at this point, I want to hand over the reins to Tracy Rolu. And Tracy, it's yours.
Great, thanks, Jammer. And thanks everybody for joining us today. I just want to say a little bit more about this last slide. So I know most of you are not economists. And so I want to just give a little bit of quick background as to how we help folks like Jammer figure out how to determine the benefits of a satellite that is going to go up in 8 years. So we're being asked to understand the potential values of a satellite that's not expected to launch till 2032. And so it's always a difficult proposition, but we have lots of tools that we can use to do that. And one of them is really on the screen. So the first thing that we did, and much of this work actually was not done by TBD Economics. It was done inside NOAA by my colleague Jeff Adkins, who works very, very frequently with the Weather Service. And what we really want to understand is what is the universe of benefits that GeoXO OCX Ocean Color observations will provide. And then more importantly, of that universe of benefits, which ones can we as economists look at that have economic data behind them that will allow us to do an analysis? And so that's the reason we focused on harmful algal blooms, is because there are a lot of economic studies out there. There's a lot of economic information on harmful algal blooms. So that's the reason that we chose this specific benefit stream, which we call it a value chain, which is what I'll talk about next. Some of the other value chains are listed there on this slide. And there's actually, I want to say 31 value chains or 22 value chains altogether that have been identified. This is just some of them. So next slide. Go ahead, next slide. So, I think I'm preaching to the choir here, folks. I'm assuming most of you are weather folks, satellite folks. So you do understand that forecasts possess no intrinsic value, right? Forecasts gain value when they help people make good decisions, right? That's the idea, is to get people to behave in a way that makes them safer, or saves money, or saves lives, or property, right? And the value of information is just that. That information has no value unless it's used in a way that makes societal outcomes better. Next slide. So that is sort of the key concept that we think about as economists, is these value chains. And so what we put together is this is a very simple format, and over the next slides you'll see it get more and more complicated. But what it really comes down to is the observation contributes to a product or a service, which then contributes to some decision, some behavior, or some outcome that improves societal, that provides societal benefits, or makes things better, reduces damages, improves quality of life, whatever that decision, behavior, outcome is. It's impacted by the product. In this case, we'll be talking about both products that are within NOAA and outside of NOAA, but very often we focus on NOAA products in general. And those, of course, as you all know, are driven by observations. Next slide, please. So the way we figure out the value of improved outcomes is also quite straightforward. You'll see on the top, we have with Geo, on the bottom, we have current this is Jeff's slide. I'd actually reverse it. I'd put the current on the top, but that's okay. We have an observation, a product, and an outcome. And then we have an improved observation, an improved product, and an improved outcome. And our job as economists is to figure out what's in the red circle, right? How the current outcomes will change. And then once we've figured out how the current outcomes will change, we can trace that back through the value chain to understand how that improved observation gets connected. Next slide. So here's where, we'll spend a lot of time actually talking about this as sort of our basic data requirements that we need to figure out this information. So again, you see observations lead to products, lead to outcomes. We know that changes in observations. Where we start actually is as I said, on the far end, on the right side, we need to understand some sort of a baseline. So if we can't have some sort of economic baseline or counterfactual, some number that we can work with to measure change from, it's difficult for us to move forward. So we tend to first focus on understanding what the baseline number that we are looking at. Then we go back and we understand how observations, improved observations or changes in observations change the products. That's step 2, and we'll talk a little bit more about that. And then step 3, of course, is the product to outcome. So how those products actually change outcomes. And you'll see that in step 1 is definitely an economic exercise. Step 2 is really a scientific exercise. We talk to scientists and engineers and folks that are in there building the satellites and putting the sensors up and creating the products and doing all of the jobs that take that observation, from launch to dissemination, and understanding what that sort of value chain looks like. Next slide, please. So as I said, we start on the right-hand side, on the baseline side of the equation. And so basically, I'm going to tell you a little bit now about how we understood our baseline. So as we talked about, we were focused on harmful algal bloom events. And so the first thing that we decided we needed to do was to understand how much harmful algal blooms cost the United States each year. And that's where we started this process. And as Jammer mentioned, this is actually the third in a series of reports that we've done on this same topic. And so the first report we did for STAR, it's actually up in the NOAA Technical Repository. And basically, the intent of that report was really to get a relatively solid baseline for the impacts of harmful algal bloom events or HAB events annually. If you can go ahead to the next slide. So how do we do that? How do we estimate the average annual impacts of harmful algal blooms? Well, we don't do economic analysis on every HAB event. In general, it's the larger and more impactful events that are studied, leaving smaller and more frequent events out of most analyses. So the first thing we did was we did a literature review. We looked at 209 studies that were related to harmful algal blooms, that were related to economics, and that were related to, that were directly connected to one of 4 key sectors, key economic sectors that we know are largely impacted by HABs. And that's commercial fishing, recreational fishing, tourism, and health. So, we're NOAA, right? So we know commercial tourism. Health isn't quite in our mission area, but certainly well connected, certainly at least on the coastal side and certainly on the weather side as well. So we're focusing now on looking through the literature, combing through the literature for papers that provide economic information on those 4 sectors. And as the slide says, we looked at 209 studies. Of those, I want to say 76 of them turned out to be usable, for which we use those 76 to develop what's called a meta benefits transfer analysis. So we basically found these papers that gave damages in this certain certain industrial sector as a result of a harmful algal bloom event. We have another database where we know all of the harmful algal the HAB events that have been reported in the United States. And we allocated the damage estimates from the economic papers over to all of the HAB events that had happened over a 26-year period. We then use GIS analysis to show the distribution of those impacts. Next slide, please. So once we did all that, here is our findings presented in tabular form. As you can see, we split the damages out by region on the left side. So we know that HAB events in different regions of the country have different types of impacts. So you're going to see beach closures and health impacts in the Great Lakes. You're going to see health impacts and beach closures in Florida. On the West Coast, it's largely fisheries, commercial fisheries, recreational fisheries, and health. And so you're hearing a theme here. Health is clearly a theme. And then on the East Coast, again, it's going to be aquaculture, commercial fisheries, and health. So our regional numbers were definitely distinct, and we learned why in our expert interviews, which I will tell you more about. But so this table presents the average annual impacts of HABs, shown both by economic sector as well as by region, and the total in the bottom right-hand corner is about $1.1 billion a year is the economic impact of harmful algal blooms, and that's in 2023 dollars. Next slide. So more importantly, and I tried to make this as big as I could, it's the distribution that matters. And so what we did find was that the distribution was pretty uniform. There, we can show you this paper so you can see it closer, but pretty much there's a lot of the sort of lower end impacts, but they're everywhere. And then you've got a few hot spots. There's hot spots in Florida, as I mentioned, Miami in particular, west coast of Florida. There's some along the Gulf Coast. There's higher impacts in the Great Lakes. Great Lakes has some very unique problems that we understand, where harmful algal blooms have actually gotten into their public water supply, because Great Lakes, as you know, is fresh water. So like, for instance, it's the city of Toledo gets their water from Lake Erie. Lake Erie had a HAB event. The HABs got into the water. They had to close down the public water system. You can imagine that's very expensive. Chicago is an outlier. We'll talk a little bit about that. That's actually, honestly, a vagary of the coastal economics data. But then you can also see West Coast impacts. There's some higher areas in Southern California, and in Northern California. And so this map just basically shows the distribution of that $1.1 billion annually to all the coastal counties in the continental United States. And I think I meant to mention it, but I may not have. We focused on the continental United States for a couple of reasons. One was because when we started this, we really didn't know to what extent GeoXO would provide observations outside of CONUS. And so that was one reason. And again, as I mentioned, this is like 3 studies in. So the first study was CONUS, so the later studies also were CONUS. And then the other piece is that the economic literature definitely tends to follow, tends to be focused in the continent of the United States. So next slide, please. So now that we have the our baseline, here's our value chain again. And you can see here we're focused on the distinction between the changes in observations and the changes in the products they support. So we've got our baseline on the right-hand side. We now want to sort of go to the left-hand side of the equation and start moving towards the baseline. So there's several methodologies that could be used to understand how improvements in observation data improve the derived products. There are OSEs and OSSEs, observing system experiments and observing system simulation experiments, which I'm sure some of you have heard of. You may also have heard of NOCEA, which NOAA uses to document the relationship between available observing systems and their impacts on NOAA's products and services. However, GEO hasn't launched yet, so NOCEA was largely unusable for us. So that leaves us with, next slide, please. Expert elicitation. And so this is really where, sorry, sorry about that. So we basically focused on talking to folks that would be able to describe to us how changes in the instruments would change the products that rely on them. So to understand the potential changes in the products and services resulting from the improvements in ocean color specifically, right? Remember, we're focused on ocean color because that's how it directly impacts harmful algal blooms. We spoke to approximately 50 scientists within NOAA. These were folks on the satellite side within NESDIS, those who understood the capabilities of the sensor, they understood the engineering behind it, they understood the improvements that were going to come along, basically the stuff that Jam represented in the beginning of this of the presentation. We spoke to the folks who run NOCEA to better understand the potential connections between improvements in the ocean color data and the products it supports, to get a list of the products that we know are connected to NOCEA. And then we spoke to folks who use the data, like those folks in NCOS and IUS and other parts on the wet side of NOAA, those who put out the products for use by NOAA partners and the public. Our goal was really to understand what would change with the new ocean color observations, because once we understand what would change, we can then take that to the folks who actually use these products and ask them what those changes might mean. Next slide. So here we are. We binned that understanding of what might change into 3 bins. Temporal resolution improvements, which is time and space. Jammer talked about that in the beginning. One of the biggest issues that folks on the ground using ocean color information have is that right now ocean color, you get 2 observations a day. You know, the satellite makes a pass twice. One of them's at night. Cloud cover often obscures the field of view, and so it's not very reliable particularly. And so the temporal resolution improvements from GeoXO, really we heard from folks that really they would be a game changer. Folks are really excited about this, about the opportunity of going from maybe 1 observation a day to as many as 6. So that was a huge improvement. We talked about the spectral resolution improvements, which Jemmer also mentioned. In the case of HABs, what spectral, a hyperspectral allows them to do is to potentially understand the difference or determine the different species that are in a bloom. So there's all kinds of algae in the ocean, and some of it's harmful and some of it isn't. And so hyperspectral will allow folks to understand the distinction between what might be harmful, what might not. Now, it's important to understand that our entire study is very much based on the continuation of the rest of sort of the observing systems, because the way it works is once they've used a satellite to identify a possible harmful algal bloom event, they then go out and use in situ measurements to confirm it, right? So, but what the spectral resolution will help them to understand is the distinction between where harmful algae versus regular algae might be. And then to basically use that in situ measurements more effectively. And then the final one was spatial resolution improvements. Now, for those of you who know satellites, you know that the current LEO satellites are obviously much closer to the Earth than the GEO is going to be. However, the OCX, the GeoOCX, provides beautiful spatial resolution. However, given what we have now, spatial resolution really was the sort of the third on the list of improvements. And once we've identified those 3 key changes from observation to product and put them into a language that folks that are not satellite scientists could understand, the next step was to understand the potential improvements from product to outcome, right? This last step that gets us to the outcome. So next slide, please. Thank you. So we use expert elicitation, which is a process that where you very carefully identify subject matter experts, ask them a series of questions. As I mentioned before, we had 50 interviews with the NOAA subject matter experts, which were helpful in guiding us to the 13 sort of, I don't want to say, but really one step back. So it's these putting out information to the public, right? The public is the end user of the information, but there's no way that folks in the public are ever going to understand this complicated value chain that I've just described to all of you. And so we needed to take a step back, and we found these folks and in universities. We found some of them within NOAA. We found them in on HABs and on coastal issues. And we had 13 interviews with these folks. Next slide, please. And so what did we find out? Our key evaluation question, again, bringing us back to now we know the changes in ocean color, and we know the total damages that HABs cost every year. Our evaluation question is, with these improvements, how much do we think that those HAB damages will be reduced? And so that is the key evaluation question. And that's the question we posed to each of those 13 experts, subject matter experts that I mentioned in the last slide. And here is some of the responses that we got. We asked these respondents to estimate what percentage of damages they thought would be reduced as a result of the improved ocean color data. So we bring them back to our starting point, that original estimates of the damages from HABs in their regions. We ask them about the different economic sectors that are impacted in their region. And then we ask for percentage estimate of reductions. Okay, and spend some time working with the respondent to refine or adjust the value. And we make sure they're confident about it. I just have 2 more slides, Jim. Next slide. Actually, I'll just skip that one and go right to the last one if we're running over. Yep, perfect. So here's our results. Basically, the previous slide sort of shows the percentages that came up from different regions. The main finding from that was that a lot of the impacts are commercial fisheries related, not what we expected. We actually expected health to be the big factor. We know health impacts are prevalent and consistent. As I mentioned, we know that health, they happen across the country. But what we happened to interview our folks on the West Coast right after Memorial Day, and they were in the midst of a giant HAB event that had happened when people had harvested both commercially and recreationally a bunch of clams that turned out to be impacted by HABs, sent 40 people to the hospital, and resulted in nationwide seafood recalls. And what we learned was that this nationwide seafood recalls are very, very expensive. Not only are they expensive, but they put doubt into the system. People don't want to buy seafood because they're worried that it might be impacted by HABs. And so that was a huge impact, something that we didn't really expect to happen. But in the end, we did some weighting approaches, which I can tell you about if you're interested. We had to do some impacts to tourism because tourism impacts were pretty much overstated in the economic side of things. But in the end, the benefit from those reductions were between 2.1 billion and 3.1 billion over the life of the sensor. So this is for the total life of the sensor from 2032 to 2055. We used a 3.1% discount rate and came up with between $2 and $3 billion in terms of value. And that's all I have. Apologies for going a little bit later.
Okay, thanks very much for an interesting presentation. I encourage attendees to stay on for the discussion. And if you're especially want to get participation from field forecast offices and regional headquarters, you can change your view to active cameras from the default view if you want to be able to speak directly to the speakers for the discussion. Please share any feedback you have on this session or the Satellite Book Club in the short survey linked that Emily has put into the chat. And come back next week, a week from today, on Thursday, October 24th, same time. Dakota Smith from CIRA will be a satellite analyst and communicator from CIRA. We'll discuss how GOES-R imagery has revolutionized how we view the weather, and ain't that the truth? Contact the Tower S team, either Kashad Bowman or Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. Okay, now I'm going to remind your attendees to submit questions or indicate if they want to ask a question verbally into the chat. So checking out the chat, let me see if there are questions. Not quite yet, but I have a question. Why did GeoXO System Program Director, you might want to identify who that is, task you to undertake this study?
Yeah, I'll answer that. Pam Sullivan, of course, is who you're talking about. For one thing, we did a previous study for her and she liked that, but that's beside the point. Primarily, she needed to justify the sensor when she comes to oversights from Congress and GAO. You can imagine that this particular sensor, the OCX, is probably the first operational ocean color sensor dedicated to ocean color, and it's kind of like a new start. And new starts are very hard to justify within the budget and appropriation system. So she wanted more fuel for that, and we gave it to her.
Okay, so it appeared to me that the economic benefit study just looked at OCX data, but of course there are other instruments on there, the GXI and the GXS and the new GLM as well. So I'm kind of wondering if you can speculate how the combination of the data might affect the economic benefit analysis, since you're just looking at the OCX, but like I said, there are lots more different satellite instruments coming.
I can speak to that from the economic side, and then maybe Jim can talk to it from the satellite side. Valuing the entire universe of benefits for GeoXO is something that requires a systems approach. It would require years and years of work. You can certainly do that, but as you know, we don't always have the time to do that. We don't always have the money to do that, and honestly, the will to do that. So, certainly from an economic perspective, we do think that a systems approach is probably a better way of doing this. But when we sort of pick these things out piecemeal, it definitely allows for a solid economic analysis that is very conservative. So our piece, as you've mentioned, Scott, only is one little piece sort of the entire validation, right? But just sort of piece by piece, it allows us to get there because we have the data. We don't have to go out and do these giant systems approaches, which would require a lot of information that really is not very easy to find.
Okay, thanks. Matt Gunshore asks, how confident are you in the current? He indicates that that's of HABs on health track.
Yeah, that's a great question. And in fact, Matt, we did the HAB damage estimates twice. And in the first one, so short answer is we think we are undercounting. But we recognize that is a problem in particular because it's like we need to get, hospital information, and there's probably a lot of people that might take a day off from work, which is an economic impact, right? That don't report anything. So for sure, but I would say between the first time we did the damages, the HAB damages, which was in the STAR study, and the second time, which was for this study, we focused very, very resolutely on better understanding the health impacts. Are we there 100% yet? No, but certainly it's better than we were when we started. But we recognize that, that's an area that really is rich for research, if you will.
And I see Steve Goodman would like to unmute and ask a question pertaining to the analysis of alternatives and mitigation. So take it away, Steve.
Hi, Steve.
Hi, can you hear me?
Yep.
Yep.
Great. So yeah, great presentation. I think many of you know I lived through this with the GOES-R program when I was the program scientist there, and Kathy Sullivan, when she was head of NOAA, would bring these issues to us from Congress on, spending or not spending money. So my question is, slide 16 speaks to me as the baseline. And then the question might be posed, what's the alternative? There's always the do nothing alternative, what you can mitigate. And then like you said, there's LEO satellites, and there are alternatives. And so, what is the incremental benefit of, say, the more frequent sampling? And I know you mentioned the clouds. So if you didn't see the HAB, say, for a day or two, what's the economic delta, when they already know there's a HAB event from other means? And so my question is what's the benefit of actually having an OCX and GEO? Because we were looking at OCX either in LEO and GEO from the fisheries folks. And so what is that delta incremental benefit? Is it big? Because Kathy was bringing us problems where, well, what if Congress is asking, what if you only did, say, 50% of the job? Is that good enough? Or 40% or 60%? How good do you need to be? And then the question that happens with severe storms is, okay, suppose you could put out a 1-hour warning, then what do you do to mitigate, say, the damage or casualties from that? Well, you got to be able to move stuff. So if it's immovable, there's nothing you can do even if you've got a warning. So I'm just curious with those two topics, how you guys address that or feel about that. Thanks.
You want to take that on, Tracy, or should I?
Sure. The short answer is it's really complicated and expensive. But the longer answer is we totally hear you. And those are all of the things that we think about when we design this kind of a study. We actually have in press a value of LEO study. So to your point, one of the things that we were thinking about as we're valuing the improvements to GEO is, the inputs from LEO and what that means. And so we did a separate study, which is still in review, on what would happen if we took the LEO took all the ocean color out completely. But in the real answer to your question is that's not what we were asked to do, right? We were asked to provide a value of the benefits for OCX on the GeoXO sensor, and so that's what we did. If we were asked to do you're talking more about a cost-benefit analysis, a trade-off analysis. That was not our charge. Our charge was to give Pam a reasonable and usable number of the benefits that GeoXO OCX will bring to the table, and so that's what we focused on. So the short answer is it's complicated. It can be done, but that's just not what we were charged to do by our client. I don't know, Jerry, if you want to add anything to that.
I just want to add to that the simple answer to that is that what we determine is the delta, because we assumed in the study that we would have all the LEO OC capabilities, even thrown in the Sentinel satellites, I think that some of the oceanographers use in their products. So what we determined was the delta above what the other satellites would give.
Yeah, we call it additive. In economic terms, it's called additive. It's the additive benefits of the GeoXO Ocean Color Sensor.
Okay, thanks. And one final question. This is from Cheng Yang Kao. You can't?
Go ahead.
Did my mic die?
No, you're back.
Yeah, one last question from.
We can hear you now.
Okay. Cheng Yang Kao is wondering how large is the US aquaculture industry and how OCX can help that sector specifically? Final answer, final question, I mean.
How big is the U.S. aquaculture is a question for NOAA Fisheries. There is a NOAA website. You probably can find that out. I don't have it right now, but I can get you access to it if you want. Aquaculture is definitely some of the folks that we talked to were heavily involved in aquaculture. When we talk about shell fisheries, in particular, that is a big sector that gets impacted by harmful algal blooms, and those shell fisheries are recreational, they are commercial, and they are aquaculture. For our intents and purposes, it's difficult because economically they kind of separate out aquaculture. They actually think about it as agriculture, and all of our economic databases count aquaculture in ag instead of in fisheries. Don't ask me, well, because most of it's on land, but anyways, but we did integrate the aquaculture pieces into the commercial fishing side of things. So certainly that is somewhat represented in the commercial fishing impacts that we describe in the report.
Okay, I think that's going to wrap it up for this. Thank you for all the interesting discussion. I'm going to pass it back to Dr. Jordan Girth.
All right. Thank you, Scott. Thank you, Jammer. And thank you, Tracy. That was a great presentation and summary of some topics we don't often cover here on the Satellite Book Club seminar series. So thanks for providing that perspective. We look forward to learning more about the OCX. Next week, the Satellite Book Club continues. It's going to be at the normal time with Dakota Smith, talking about how GOES-R imagery has revolutionized how we view the weather. In the meantime, if you have any questions for the TowerS team, Kashad and Emily are always available. You can all reach them via email or through the Slack channel. Don't hesitate to reach out. With that, we'll wrap it up for today. Hope everybody's fall is going well. Thank you so much again for attending today, and thanks again to our presenter and facilitator. Take care.